Hello dear students, welcome to this new session. As you know that we are studying class 10 ICSE first chapter, which is force, work, power and energy. So in today's session we will discuss about conservation of energies principle and we will verify it theoretically. So first of all we will discuss what is the principle of conservation of energy. So this principle says that energy neither can be produced nor it can be destroyed. What we can do, we can only transfer energy from one form to another form. Means in this universe there is a limited energy and this limited energy neither can be increased nor we can decrease it. It will fixed. Only thing we can do, we can convert energy from one form to another form. In our daily life, we have a lot of examples where we convert energy from one form to another form. As you can take the example of solar energy. We take the sunlight's solar energy and convert it into electrical energy. Similarly, there must be washing machine in your home. What it does, it converts electrical energy into mechanical energy. When a bulb glows, it converts electrical energy into light energy. So there are so many examples where we can see that energy is converting from one form to another form. When you run your car or bike, then chemical energy is converted into mechanical energy, right? So these are some of the examples where the energy is being converted. So according to this principle, we can write down that energy neither can be produced nor it can be destroyed. We can convert energy from one form to another form. So this is simple definition of the principle of conservation of energy. Energy can't be increased. You want that you should increase some energy. It is not possible. Or you want to destroy some energy. That is too not possible. Only you can convert energy from one form to another form. You throw a ball, then you are doing some kinetic energy to this ball. And when ball strikes on a wall or on a surface, and it stops after some time, then where is your kinetic energy? Where your kinetic energy gone? It has been converted into sound energy as well as into heat energy. So it is only converting its form. You can't destroy the energy. You are here not destroying the kinetic energy. This kinetic energy is changing into heat and sound energy, right? So this is the definition of principle of energy. Now we will verify this principle theoretically. So let's see, how can we verify? Suppose this is the ground level, we'll take it A, okay. A ball is there kept, we lift this ball and keep it at certain height H, here. We kept this ball here at this height. Okay. Now, at this height, okay, this is the ball kept here at H height. Okay. This is A level and this is B level. Now, this ball must be having some potential energy, right? Because we lift it from ground to h height at point B. So it is having some potential energy. Okay, we will take another point somewhere in between. Suppose that this is x distance, right? And we will consider this point as C. So now what we are going to do, we are going to calculate the total energy of this ball at 3 different positions. We will calculate the total energy of this ball at, first of all, at B, then we will calculate its total energy at C, and then we will calculate its total energy at A point, right? So these are 3 different locations, positions where we will calculate its total energy. So first of all, we will calculate the total energy means what? Mechanical energy means what? Potential energy and kinetic energy if it is, right? So first of all, at point B, so the ball is kept here. So if it is kept, it is not moving, it is in a stable condition, it is in static condition, right? So it is not moving. So the kinetic energy of the ball will be 0. So at point B, kinetic energy will be 0. What about potential energy? Potential energy is equal to the weight of the ball is mg. Suppose that the mass of the ball is m and g is the gravity towards the Earth's center. So its weight will be mg, and the displacement is h, mg h. As we know that work done is only the potential energy. Whatever work I did to lift this ball from surface to certain height, then I did some work. That work done will be known as its potential energy. How much work I am performing, that is stored as potential energy in this ball. So when I am uplifting this ball, I have to use some work, I have to use some force. What is that force? That force is mg. When I am uplifting this ball, then I have to apply some force against the weight of this ball, and the weight of this ball is mg. So force is mg, and displacement, what is the displacement? S is h here. So what is work done? Work done is nothing but W is equal to F multiplied by S. So F is mg and S is h. So that is why I wrote the potential energy mgh. Okay. So what will be the total energy? Total energy, it will be mgh. 0 plus mgh is equal to mgh at point B. Okay. So we calculate the total energy at point B. Now we will calculate the total energy at point C. So at, we'll use the different color, okay, at point C. Let's see. One thing very important here, when we are using the potential energy, then we will calculate it from ground. And when we are calculating the kinetic energy, then we will calculate it from top. Just write down this. This is very important. For potential energy, displacement will be taken from ground, right? While for kinetic energy, displacement will be taken from highest point. This point is very important. When you are going to derive this, then must consider this point, okay? So in this point C, at point C, we will use these 2 points. So at point C, first we will calculate the kinetic energy. Now there must be some kinetic energy, okay? So first of all, we will calculate the kinetic energy. Now the ball is moving. It is coming here at this position C, okay? So this is coming at this position C. So it is having some velocity V. So what will be that velocity? We can calculate it with the help of motion's equation. V square is equal to U square plus 2AS. So U initial velocity is 0. Here the velocity was 0 when it was kept here. Initial velocity was 0 and final velocity is V. So V square is equal to 0 plus 2. And what is the acceleration? Acceleration is due to gravity. Earth is applying some force on this ball, right? So acceleration is due to gravity, 2g. Now what will be the displacement? The total height is h and it has covered x distance. So what will be the displacement? As I said that kinetic energy will be taken from top. So this much distance is h and we have covered x distance. So the remaining distance will be h minus x. H minus x. This distance is remaining. Okay. Means we have covered this much of distance. H minus x distance this ball has covered. Okay. So what we will get? V square is equal to 2gh plus 2g plus minus minus. We'll open the bracket, then plus minus minus 2gx. So this is the equation V square. Now kinetic energy is equal to half mv square. Okay. So half m will put the value of V square 2gh minus 2gx. What we will get? We will get half m into 2gh minus half m into 2gx. Right. So 2 will be cancel out. Here 2 will be cancel out. We'll get mgh minus mgx. Right. So this will be the kinetic energy. This will be kinetic energy at point C. Now we will calculate what will be the potential energy at C. Okay. So what will be the potential energy at point C? Potential energy, work done is equal to force into displacement. So force will be mg and displacement will be x. So PE is equal to mg and displacement is x, mgx. So total energy will be, total energy is equal to kinetic energy plus potential energy. So what we will get? mgh minus mgx, mgh minus mgx plus mgx. So these two will be cancel out. So total energy will be mgh. mgh. This is total energy at point C. Have you got it? This will be the total energy at point C. Now we will calculate the total energy at point A. What will be the total energy at point A. Ball is continuously coming towards the ground. Right now it has reached on the ground. So now H became 0. Displacement became 0. So potential energy at point A will be 0. We'll write down somewhere here. And we'll change the color. Okay. Total energy at point A. Okay, at point A. So kinetic energy Ke is equal to half mv square. So what will be v square? V square is equal to u square plus 2as. What will be u square? 0. So 0 plus what will be a? 2g. A will be, acceleration will be due to gravity. So 2g. And what is the displacement? It is h. Displacement is h. So it will be 2gh. We'll put value here. Then what we will get? K is equal to half m into 2gh. So this 2 will be cancelled out and we will get mgh. Right. So this is the kinetic energy at point A. What will be the potential energy at point A? mgh, and h is equal to 0 here. Potential energy at A. Right. H is equal to 0 at A. Hence, mg into 0 is equal to 0. So potential energy is 0. So what will be the total energy? Total energy is equal to potential energy plus kinetic energy. So total energy will be mgh. So this is what the total energy at point A. At point A. Okay. So at point A we are seeing the total energy is mgh. At point C we are seeing that total energy is mgh, and at point B the total energy is mgh. So at any point if you will consider, the total energy will be mgh, means it is conserved. It is conserved, neither it is increasing nor it is decreasing. Only it is converting from one form to another form. Kinetic energy is converting into potential energy and potential energy is converting into kinetic energy. Nothing else is happening here. Here the potential energy is 0, right? And the kinetic energy is maximum. When the ball dropped, the kinetic energy will be maximum because velocity will be maximum. So here the potential energy is 0. As we move up, the potential energy is increasing and kinetic energy is decreasing. When we throw a ball upward, its velocity continuous decreases due to the force applied by the Earth's gravity, due to which there is a retardation. Okay, so its kinetic energy is continuously decreasing while potential energy is increasing. At this point B, the potential energy will be maximum while kinetic energy will be 0. So all the kinetic energy which was at point A will be converted into potential energy at point B. Got it? So what is happening here? The energy is being converted from one form to another form, and this process is continuous. As we move upward, the kinetic energy start changing into potential energy. As we come downward, the potential energy start converting into kinetic energy. So there is a conversion of energy, but the total energy is conserved, is fixed, which is mgh at any point. Whether we will take at this point or this point or this point or this point, at any point if we will calculate the total energy, we will find it mgh. So this is how we can verify the principle of conservation of energy. Hope you understood this principle very well. So now we will move on the next slide. What does it say? Application of principle of conservation of energy to a simple pendulum. Now we will try to understand the conservation of energy with the help of a pendulum. So let's see. As you have seen, suppose that this is, we hang a ball with the help of a thread, right? This is thread fixed here, and a ball is hanged with the help of this thread. Now, we use some force and move it at this direction, and the ball reached here. By using some force, I disturb this from mean position to this position. Suppose that this position is A, this is mean position. Okay, I disturb this ball at point A. So what I did, when I am moving it towards the point A, then I am applying some force on it. I am doing some work. So where though that work is going, that work is storing in this ball in the form of potential energy. So as I am using more and more force, more and more potential energy is stored in this ball. At point A, the potential energy will be maximum. At this point, the potential energy will be maximum. Why? Because I am continuously increasing my force. That is why I am continuously doing some work. I did work at till this point A. So at point A, till point A, I have applied the maximum force which I was having, okay? So till that point, I used a lot of force and reached the ball at point A. So here, the all work I did is converted into potential energy. Hence, we can say that at point A, the potential energy will be maximum. What will be the kinetic energy at this point? At this point, the kinetic energy will be 0 because I am holding it here. So what is kinetic energy? Ball is not moving. So at this point, kinetic energy is 0. As I will release this ball, till I was holding this ball at point A, the kinetic energy was 0. When I release this ball, now the ball will start moving towards its mean position, right? Now the ball will start moving towards its mean position. Hence, the potential energy will start converting into kinetic energy. Whatever the potential energy it was having, now this potential energy will start converting into kinetic energy. So potential energy is decreasing. Potential energy is continuously decreasing and kinetic energy is continuously increasing, right? When we will reach at midpoint, at mean position, at this time, the kinetic energy will be maximum. At this point, the kinetic energy will be maximum. Means what? All the potential energy has been converted into kinetic energy. So, kinetic energy will be maximum, but potential energy will be 0. Potential energy will be 0. Okay? Why? Because whatever the potential energy was, that is continuously converting into kinetic energy. So, at this point, all the potential energy has been converted into the kinetic energy. So, the kinetic energy will be maximum at mean position, while the potential energy will be 0. Now, since the ball is having the kinetic energy, so it will not stop here. It will go further and will reach at this point B. Now, this ball is continuously moving as it was having the maximum kinetic energy. So, now it is start moving and reach till the point B. So, what is happening at this path? At this path, the kinetic energy is continuously converting into potential energy. So, the kinetic energy is decreasing and potential energy is increasing. Why? Because kinetic energy is now converting into potential energy. When the ball will reach to the maximum height, all the kinetic energy has been converted into potential energy. So at this point B, the potential energy will be again maximum and kinetic energy will be again 0. Why? Because all kinetic energy has been converted into potential energy at this point. Now again the ball is having the maximum potential energy and its kinetic energy is 0 at point B. Then again it will move towards the mean position. So again the potential energy will be converted into kinetic energy, and at this mean position the kinetic energy will be maximum, hence it will keep on moving towards the A and the energy will continuously keep converting from one form to another form, from kinetic energy to potential energy or from potential energy to kinetic energy. So this is what the conversion of energy. So with this we can understand the principle of conservation of energy to a simple pendulum with the help of a simple pendulum. How the energy is conserved. If you will calculate energy at any point, suppose you are calculating energy at this point. So half of the potential energy has been converted into kinetic energy and the half value will be the kinetic energy and half value will be potential energy. So it will be fixed. Whatever the potential energy, whatever the total energy is here, suppose that total energy is here mgh. So it will be mgh at this point 2, it will be mgh at this point 2, at this point 2, at this point 2, at this point. At every point the total energy will be conserved. Hope now you have understood the concept of conservation of energy, right? So moving ahead. Okay, so that's all was for today's session. Hope you understood it. So now I would like to wind up this session with this beautiful quote, and this quote is given by me only. An object gets charged when it is rubbed. Means what? Charge means what? An object, when an object is neutral, then it doesn't have any power to attract or repel any other object. As it gets charged, it has the power to attract or repel other object. And how it gets charged? When it is rubbed with any other object. Similar happens in our life too. If we will utilize our potential, if we will continuously do work hard, then we will be charged. Otherwise, we are neutral. If we will not work hard, we are in neutral condition. We don't have any power to attract or repel any other object, means all the powers are neutral. If we will be charged, how we will be charged? When we will do a lot of work. During the rubbing, there is a lot of work being done. So when we will do work hard, we will be rubbed and then we will also have powers. So with this beautiful quote, I would like to wind up this session over here. We'll meet in the next session. Till then, take care of yourself. Have a great time.